Okay, lesson 3.4. My plan is to get through these notes. I'm looking at, we may have to skip example 3, which is the graph. Okay, just because of timing today, because we had 2 homeworks to check. But the rest of it we should be able to get through, okay? Lesson 3.4 is our properties of logarithmic functions. Just some properties about how logs work. How can we manipulate the logs? How can we use logs? If we were going to have time to do lesson 3.5, it'd be solving equations. And how do we deal with the logs when we're solving equations? Those type of pieces there. So 4 rules here. The first rule is our product rule. And the product rule says log base b of r times s is equal to log base b of r plus log base b of s. So what I would interpret that to say is if you have a log where there is multiplication within the log, so it's r times s, right? Multiplication within the log, that can be rewritten as 2 separate logs being added. So notice it starts off as 1 log with multiplication, goes to 2 logs being added. This can also be reversed. You can also see it of the form if there's 2 logs being added with the same base, it can be rewritten as 1 log where the insides are multiplied. So that's your product rule. Of course, multiplication and addition go together. We also have the quotient rule, which is going to be similar to the product rule. Quotient rule says if you have a log where the insides are being divided, then that can be rewritten as 2 logs being subtracted. So if there's a log with division inside of it, rewritten as 2 logs being subtracted. Of course, this also means if you have 2 logs being subtracted and you want to put them into 1 log, you can put them into 1 log where the insides are being divided. We have the power rule. The power rule, again, these are things helpful in solving equations and working with them. The power rule says if you have a power on the inside of your log, so log base b of r to the c, that power can be moved out front. So it can go from the exponent to a coefficient and be rewritten as c times log base b of r. Okay, so a power exponent here can also be a coefficient out there. And lastly, change of base rule. This is helpful if you're trying to do something on the calculator, but it's not in log 10 or a natural log. So the change of base rule says log base b of r can be rewritten with another log or with another base. So log base b of r could be rewritten as the natural log of r divided by the natural log of b. So notice it's the natural log of the inside divided by the natural log of the base. It can also be rewritten as common log. So log base 10 of r divided by log base 10 of b. Change of base formula really means that this log base b, it could be rewritten in this fraction form with any base. We usually pick natural log or log base 10 because those are the calculator buttons. And that's where change of base formula comes into play, is because you can use the calculator buttons easier there. So it's, whether you're doing natural log or common log, it's the log of the inside divided by the log of the base. Okay? Ready to try some of these? We're just going to do some examples here where we're just practicing using these properties and becoming familiar with them. So number 1 says to expand. Right now it's written as 1 log. If we're going to expand it, we're going to write it as multiple logs. So basically we're going to use all these rules up above that we can to get it to expand. So log of 8xy to the 4th. Thoughts? What do you see? What? Okay, so as you first look at it, do you see multiplication happening within this log? What's being multiplied here? Technically, what are you going to say if I say there's 3 things being multiplied? Do you see 3 things being multiplied? And And we could break it into 2 first, but we're still going to have to eventually break it up. So if we break that into 3 things, we have an 8 times an x times a y to the 4th. So product rule says we can break it into, or multiplication within one log can be rewritten as multiple logs being added. And so first thing I'm going to do is I'm going to say the log of 8 plus the log of x plus the log of y to the 4th. Okay, so that's expanding. There's a little bit more we can do with this. Other thoughts? Ethan?
The power rule.
Okay, power rule. I'm assuming you're looking at the power rule here on y to the 4th. Means the power of that y can be rewritten out front as a coefficient. What if I say you might see the book use a power rule someplace else here too?
This is correct on this, but would they put the 4 in front of log 8?
Would they what?
Put the 4 in front of log 8?
No. I'm assuming you're talking about that 4 there?
Yeah.
Yeah, no. That 4, since it's a power on y, it just goes right in front of that log. X obviously only has a power of 1. What do you know about 8? Yeah, 8 can be rewritten as 2 to the 3rd. As I said, the book tends to do this. So what they'll think is they'll say, okay, log of 8. Can we agree that log of 8 is the same as log of 2 to the 3rd? And now what do I have? I have a power, and that power can go where? Out front. Now, I'm a little flexible, with that log of 8 becoming log of 2 to the 3rd, but I think it's something good to be able to recognize. So if I bring that 3 out front, this is going to be 3 log of 2 plus, I still have log of x, plus log of y to the 4th becomes 4 times log of y. And this would be your most expanded form there. We took one log and we pulled it apart as much as we could. Questions there? Okay, let's try number 2. Oh, yes.
Are you always going to use more than one property in each equation?
I don't know if I would say you always will, but it is likely to use multiple properties within one expansion problem. Okay, so. Okay, 2, we got another expand. It's a natural log this time. Natural log of square root of x squared plus 5 over x. Thoughts here? What do you see first? Quotient rule? There's division, yes? Division inside of a log can mean the log can be rewritten as 2 logs being subtracted. So let's start there. I'm going to say natural log of square root of x squared plus 5 minus natural log of x. When we say natural log, that is an LN, correct? Don't ask why the abbreviation is LN for natural log, but it is. Okay?
N's natural, L's log.
I know, but
So it's log natural.
I know, but see, then I always get the question, well, why is it backwards?
Those look weird. L looks better with LA.
I feel like log begins with L, so natural log needs, the abbreviation needs to begin with L, but again, we can guess all we want, but I don't know the answer. Okay, so am I done? Or is there more we can keep doing? We can't square the square root, but I do need to do something with that square root. as you're trying to do, I can tell. Yeah?
Can you take that and put it into like a exponent?
Yeah, what is square root as an exponent? 1/2. So here's the kind of intermediate step I'll write in. Natural log of that square root is really natural log of x squared plus 5 raised to the power of 1/2. And so if I take that square root of x squared plus 5 and move that square root to a power of 1/2, where can that 1/2 go? That 1/2 can go out front. And so I can say 1/2 natural log of x squared plus 5. What about this minus natural log of x? It doesn't have any special power or anything, so it's just minus natural log of x. Okay. Don't fall into the trap of trying to expand this addition. Okay? That would be a common mistake I think I would see going from here is, oh, there's addition within a log. I can make it multiple logs being added or subtracted. No. You can take multiplication in a log and make it multiple logs added or subtracted. But addition in a log, you can't do anything with that. Okay, so that was expand. Use those properties, dissect that one log, pull it apart. Now we've got to condense. So basically, we're going to go the opposite direction of what we just did. We're going to take these multiple logs, and we're going to put them into one log in the end. Now, in order to do that, what do you think we should do first? Think about what we were using last on most of these. What do you notice all of those logs have in front of them? They all have numbers in front of them. So if we're going the opposite direction we kind of went last time, we're going to use the power rule first. In other words, no, you can't go and use a quotient or product rule until they are just logs of something. There can't be coefficients. So we need to get those coefficients out of the way. Now, how do you guys feel if we also have subtraction and then addition. Can these pieces be rearranged, or would that make you guys not happy? And here's my reasoning. As I start thinking after we do the power rule, so we're going to move all these powers up, right? All these coefficients into powers. We're then going to have to think product and quotient rule, right? We see where that's going. I don't know about you guys, but my brain thinks better if I have my product rule first and then my quotient rule second. It's not that it has to be that way. But so what I would say here is, okay, I'm going to have natural log of x to the fifth. Can I go ahead, will you guys be okay if I go ahead and say plus natural log of y to the third? And then I'm still going to have the minus, but I'm going to leave it at the end, minus natural log of xy quantity squared. My reasoning for doing that is I think the product and quotient rule will work a little bit better that way. If you left it the other way, it's fine. Okay. From here, you can do this all as one step if you want. I'm not sure I want to do that as a first time with the class, but you could. But if I take it in baby steps, the first thing I'm going to see is a product rule, right? So what is natural log of x to the fifth plus natural log of y to the third? Oh, I shouldn't have done that all in one step. Oh, well. Hopefully I didn't lose you guys too much. Two logs being added can be rewritten as 1 log where your insides are being multiplied. So I just wrote that as natural log of x to the fifth y to the third minus natural log of xy quantity squared. I did put parentheses there because I want to indicate that it's all inside the log. Now, you see your division, yes? 2 logs being subtracted can be rewritten as 1 log where the insides are divided. X to the fifth, y to the third, over x, y. You know what I should probably do? What is xy quantity squared?
X squared, y squared.
X squared, y squared. Now, there's a reason I'm suggesting that I change that here. If I remove those parentheses and say it's x squared, y squared, do you see why I might do that? Is there some cleanup that can be done here? Yeah, and that's my reasoning, is that there's some cleanup that can be done. What do you know about x to the fifth over y to the third? Don't even ask. What do you know about x to the fifth over x to the second? That is x to the third, because 5 minus 2 is 3. What do you know about y to the third divided by y to the second? Y to the first, because 3 minus 2 is 1. So the answer I would end up with is natural log of x cubed y. Are there different orders and ways to get to that same answer? Definitely. Power rule needs to happen first. If you wouldn't have rearranged things and you would have done a quotient rule and then a product rule, it can work. I just think it's easier to have your products at the beginning, your quotients at the end. Personal opinion. Questions on that one? Okay. Time-wise, we're definitely not doing example 3, which goes with what I changed the homework to be. We do need to do example 2. Okay? So don't worry about this stuff. Evaluate the following using the change of base rule. So when you look at the log buttons on your calculator, you can't do log base 3 of 16 using your log buttons. Okay? So, change of base rule up above said, we can change these to any base we want. What base buttons do you have? You got a log base 10, right? So I could rewrite this and say that this is log of what? Inside divided by log of the base. So log of 16 divided by log of 3. Now, I picked that just because I did. What's the other option you could do? Do you have to use log base 10? No, you could use natural log of 16 divided by natural log of 3. Guess what? It's magic. Your calculator's going to give you the same answer either way. Okay? Did anyone do it? Did you get an answer? I have 3 decimal places written down. I would try it. Make sure you can get your calculator to cooperate. Did you get something along the lines of 2.524? Okay, that's all change of base formula is okay, basic calculators don't have log base 3 button. So I use change of base to be able to do that. There are times solving equations, graphing, that change of base formula is good to know also, which is why we need to learn it. Okay? So what about number 2? What do you do in number 2? If it's log base 6 of 10, we could rewrite it how? Log of 10 divided by log of 6, or natural log of 10 divided by natural log of 6. Play with it on your calculator. Make sure you get it to work out right. I have 1.285. Number 3 does say log of 2 base 1/2. if you can read that. So that means I could do log of 2 divided by log of 1/2, which, to be honest, what's easier to enter on the calculator? Log of 0.5. Or natural log of 2 divided by natural log of 0.5. Either way there, I get -1. Your homework is on page 289, 1 through 28. Random questions, you guys are cleaning up. Has anyone discovered that these calculators can actually do any log? No one's dug that far into these calculators?
I think I've seen it somewhere.
I don't know what you're talking about. Mrs.
Okay, so Ethan's found it. That's what we know.
No.
There is you guys need to know change of log formula, but yes, there is a way that these calculators can do any base.
Well, see, these bad boys do a little bit more than that too.